Yeah, children, we have just finished series combination. Okay, we are going with parallel combination of the springs. Actually, why we are supposed to discuss these combinations means in a mechanical system, suppose if you are solving the mechanical system, we are asked to solve certain uh, mechanical systems in which springs are involved. Suppose 4 to 5 springs are involved or 10 springs are involved. Better to reduce them, those 10 springs, into 2 spring or 3 spring system. We can analyze easily. Yes, that's why we are using these techniques of series combination and parallel combination. Am I right or wrong? Yes or no?
Sir.
Yes.
Yes.
Yes, sir.
You have seen a example also in series combination. Okay, how the 2 springs reduce it to a single spring and the situation becomes simple. Okay, clear. Now,
Yes, sir.
so in a mechanical system, they will ask to find certain parameters to find that, yes, if number of springs in the mechanical system, if number of springs are more, it will be easy, or if springs are reduced, number of springs are reduced, it will be easy. In which case it will be easy
Reduce
to,
this.
yeah, number of springs should reduce. We should make a complex system into a simple system, mechanical system. Okay, right. Let us see the things here. Okay, my dear children, here I'm going with the combinations, parallel combination. Two springs, spring 1 and spring 2. With a block of mass m. Yeah, here the spring constant is k1, here k2. I should replace this system with a single spring equivalent system. I should replace this system with a single spring. Got the point, my dear?
Yes, sir.
Yes, sir.
For that, I should replace it with a single spring. Okay, instead of these two springs. And this is a block, same block we have. Same block we have. Okay, mass,
Sir.
mass m. And here, my dear children, I have applied a force F here, and here also F. Okay, here in connection with these two springs, how the block responds to this force is it get displaced by x naught. The same block, yes, in connection with a single spring whose spring constant is kp. Yes, how it responds means it should respond in the same way. It should respond in the same way. Then only it will be called as an equivalent spring for these two springs. Got the point? What
Yes,
these
sir.
two springs are together doing, the job done by these two springs together should be done by a single spring. Got the point, my dear? All of you.
Yes, sir.
Yes, sir.
Yes or no?
Yes, sir.
Yes. Issue is so simple. Na?
Yes, sir.
Yeah. Now, बात पक्का है ना जी? Yes.
Yes, sir.
Right. Let us go with the things here. Here, if this block displaces by x naught right side, okay, what is the elongation in this spring?
X naught, sir.
In this also?
X not.
Naught, sir.
X naught. Very good, very good. You see, my dear, this is spring force 1, this is spring force 2. Am I right or wrong?
Right.
Right. Here also some spring force Fs. The condition is equilibrium. Both cases, the block is in equilibrium. So when it is in equilibrium, Okay, F is equals to Fs1 plus Fs2. Okay, my dear. Here F is equals to Fs. Okay, what is elongation in this spring? X naught. Why? Why X naught? Because the block displaces by X naught. That's why the elongation is X naught. So F is equals to K1 X naught plus K2 X naught. I'm right or wrong? Yes, sir.
Right.
Spring force is given by spring constant times the elongation or compression. Here elongation. So how the spring force is given by? Yes, spring constant times the deformation. Deformation in sense it may be elongation or compression. I already said these things. Okay, right.
Yes, sir.
What is Fs here? Kp into X naught. Okay, so here F, here also F we got relation. From this we can write K1 X naught plus K2 X naught is equals to Kp X naught. Sorry, Ks. This is Ks, no? Kp or Ks? Kp only, sorry. Kp X naught. So Kp is equals to K1 plus K2. Your favorite part in mathematics is cancellation.
Translation.
So you got the point, my dear, all of you. So this is the condition S for the springs in parallel combination. You see, suppose if I take, my dear children, if I take this spring constant as 10, this as 20. Okay, I should replace these two springs with a single spring. Then I should take a spring whose spring constant is
30, sir.
30. 10 plus 20 is equal 30 Newton per meter. Issue is simple or complicated?
Simple, sir.
So replacing two springs with a single spring, it is very simple. So in the same way, I will give one more question to you. You should answer me now. Okay, you are ready to answer me?
Yes, sir.
This is a block M. Okay, and springs are connected. Spring 1, this is spring 2, K1 and K2. This is M. I should replace with a single spring here. I should replace with a single spring. Okay, I should have an equivalent system. I should have a equivalent system. I should replace with a single spring. What these two springs are able to do, a single spring should do that. Okay, same mass M. Okay, same mass M. Instead of two springs, how many springs I'm going to use?
One, sir.
Only one spring.
Sir.
Yes.
One, sir.
Okay, clear. This is a 10. Okay, let us go for the equilibrium condition now. Let us go for the equilibrium condition. Yes.
Yes, sir.
I am applying a F force here. Here also F force. F and F. Now on this block, two springs will apply forces in which direction? Can you say? This spring will apply left side force. Why? Spring is elongated. Yes or no?
Yes, sir.
Yeah.
Sir.
This spring is compressed. So this spring also will apply force in this direction only. Yes or no?
Sir.
Yes, sir.
So, my dear, if the block gets displaced by x naught here, here also it displaced by x naught. So, in this elongation is x naught, in this compression is x naught. I'm able to, you are able to understand?
Yes, sir.
Okay. When this block get displaced by x naught towards right, the spring gets elongated by x naught. The spring get compressed by x naught. Elongated spring will pull it. Compressed spring will, yes, what it will do? Push it like this, left side. Okay, now both
Yes,
forces
sir.
are left side only. Okay, so here, my dear, what is this spring force 1? This is spring force 2. And this block is in equilibrium. F is equals to Fs1 plus Fs2. Here, spring force is like this, Fs. Here, Fs is equal to F. Can you say what is this Fs? K, some K dash x naught. K dash x naught is equal to F. Okay. Here, what is this? F is equal to Fs not mean Fs1 means what? K1.
K1 X
K1
Fs2 means what?
K2 X
K2.
K2 X naught, sir.
From these two, we can equate what? From these two, we can equate. From these two, we can equate K1 x naught plus K2 x naught is equals to K dash x naught. Your favorite part in mathematics is cancellation.
cancel.
So K dash is equals to K1 plus
K1 plus K2, sir.
it looks to be what combination? Parallel or not?
Parallel.
Yes, sir.
So
Parallel.
that's why I call this as a parallel combination. You understood, my dear children?
Yes, sir.
Yes or no?
Yes, sir. Yes, sir.
Just by seeing the configuration, don't judge it parallel or series. It seems to be series. You may say, sir, this is in the single line, sir. It may be series. Don't judge the book by its cover page. Okay, got the point? Just don't judge it is a series or parallel combination by just seeing the figure. Don't judge it. The mechanism we should work out. Okay, right, my dear children?
Okay.
All of you.
Yes, sir.
So this is about your parallel combination. Okay, dear?
Okay, sir.
Yes, sir.
Right.